Dear students, welcome to digital learning platform of Department of Collegiate Education. We have been discussing the concept of compound interest and its applications in the previous sessions. So in these sessions, we shall discuss the concept of compound interest when the rate of interest changes from year to year. That means the rate of interest will not be fixed for whole the period, but it goes on changing from year to year. So the prerequisites of the session are the concept of interest, principal and amount, and formula for computing the compound interest, which we have already discussed in the previous sessions. So formula for computing the compound interest is A equals P into bracket 1 plus R divided by 100 raised to N, where P is the principal, R is the rate of interest per annum, and N is the period in years. Amount represents A represents amount. Similarly, CI equals A minus P. A means amount, P means principal, CI is the compound interest. So varying rates of interest. Sometimes the rate of interest, instead of being the uniform throughout the period, goes on changing from year to year, or it changes at the end of certain number of years. In such cases, we cannot take the same compound interest formula. In these cases, we have to make certain modifications to the formula, and formula to be used will be P into bracket 1 plus R1 divided by 100 raised to N1 into bracket 1 plus R2 divided by 100 raised to N2 into bracket 1 plus R3 divided by 100 raised to N3, like this. If there are three rates of interest, then you have to take R1, R2, R3 and corresponding periods as N1, N2, N3. If in the problem they have given 4 rates of interest, you have to take 4 rates of interest, R1, R2, R3, R4, and corresponding period says N1, N2, N3 and N4. So here P represents amount, N represent period in years, R represent rates of interest, and A represents amount. Compound interest equals A minus P. A represents amount and P represents principal. So let us discuss this concept with an example. A person borrows rupees 1,80,000 at the rate of 8% for first 3 years, 12% for 4 years, and at 14% for remaining years. Find the compound interest payable at the end of 10 years. So dear students, we have to find out compound interest at the end of 10 years. The principal amount is the 1,80,000. Sum borrowed is rupees 1,80,000. The rate of interest was 8% for the initial 3 years. Then it was 12% for next 4 years. And it is 14% for the remaining years. Remaining years means totally 10 years minus 3 years minus 4 years. That is 3 years. So rate of interest is 8% for 3 years, 12% for 4 years, and 14% for 3 years. So they are given R1 as 8% and N1 as 3 years, R2 as 12% and N2 4%, R3 as 14% and N3 as 3 years. Principal is 1,80,000 and we have to compute compound interest. So amount equals P into bracket 1 plus R1 divided by 100 raised to N1, R2 divided by 100 raised to N2, and 1 plus R3 divided by 100 raised to N3. Here they are given 3 rates of interest, so we have to take R1, R2 and R3 and corresponding periods as N1, N2 and N3. So now A equals P is 1,80,000 into bracket 1 plus R1. R1 is 8% raised to 8% divided by 100. A divided by 100 raised to N1. N1 is 3 years into bracket 1 plus R2 12% divided by 100 raised to N2. N2 is 4 years into bracket 1 plus R3. R3 is 14%. 14 divided by 100 raised to N3. N3 is 3 years. So now A equals 1,80,000. 1 plus 8 divided by 100 is 1.08 raised to 3. 1 plus 12 divided by 100 is 1.12 raised to 4. 1 plus 14 divided by 100 is 1.14 raised to 3. Now if you apply laws of logarithm, the product sign is replaced by positive sign and the index or power will be replaced by multiplication sign. So therefore log A equals log of 1,80,000 plus 3 into log of 1.08 plus 4 into log of 1.12 plus 3 into log of 1.14. So A equals log of 1,80,000 is 5.2553. Here there are 6 integral digits. So 6 minus 1 is 5. 5 is the characteristic. And multiply value for 18th row 0 column is 2553 plus 3 into log of 1.08 is 0.0334. One integral digit minus 1 characteristic is 0 plus 4 into log of 1.12 which is 4 into 0.0492. 3 into log of 1.14 is 3 into 0.0569. So now log A equals 5.2553 plus 3 into 0.0334 is 0.1002 plus 4 into 0.0492 is 0.1968 plus 3 into 0.0569 is 0.1707. So now if you add all these log values together, log A equals 5.723. So A equals antilog of 5.723. A equals 5,28,400. Here the characteristic is positive and it is 5. That means number of integral digits will be 5 plus 1, 6. Antilog value for 0.723 is 5284. Since characteristic is 5, so 5 plus 1, 6 integral digits will be there in the result. That means the amount is 5,28,400. Now compound interest equals 5,28,400 minus 1,80,000 principal amount. Compound interest is rupees 3,48,400. Similarly, out of the four quantities A, P, R and N, if 3 are given, you can find out the remaining quantity. So in this question they have asked us to find out sum or the principal amount and they have given the amount. Find the sum borrowed at compound interest if a person pays an amount of rupees 45,000. So 45,000 is the amount at the end of 5 years. The interest being charged at 4% for the first year, 5% for the next 2 years and 6% for the subsequent years. 5 years minus 1 minus 2, 3. Minus 1 minus 2 is 2 years. So subsequent years are 2 years. So rate of interest is 4% for the first year. R1 is 4 and N1 is 1. R2 is 5% and N2 is 2 years. R3 is 6% and N3 is 2 years. R1 4, N1 1, R2 5, N2 2, R3 6, N3 3. So now A is given, we have to compute principal amount. So formula for computing the amount in case of multiple rates of interest are P into bracket 1 plus R1 divided by 100 raised to N1 into bracket 1 plus R2 divided by 100 raised to N2 into bracket 1 plus R3 divided by 100 raised to N3. So here amount is the 45,000. P we have to find out P as it is into bracket 1 plus 4 divided by 100 raised to 1 into bracket 1 plus 5 divided by 100 raised to 2 into bracket 1 plus 6 divided by 100 raised to 2. So 45,000 equals P into bracket 1 plus 4 divided by 100 raised to 1 is 1.04, 1 plus 5 divided by 100 is 1.05 raised to 2. Similarly, 1 plus 6 divided by 100 is 1.06 raised to 2. Now, when you apply laws of logarithm, log 45,000 equals log of p plus 1 into log of 1.04 or just log of 1.04, 2 into log of 1.05 plus 2 into log of 1.06. Log for 45,000 is 4.6532 equals log p plus log of 1.04 is 0.0170 plus 2 into log of 1.05 is 2 into 0.0212 plus 2 into log of 1.06 is 0.0253. That means 2 into 0.0253. Now 4.6532 equals log p plus 0.0170. 2 into 0.0212 is 0.0424 plus 2 into 0.0253 is 0.0506. 4.6532 equals log p plus 0.0170 plus 0.0424 plus 0.0506 is 0.1100. So now 0.1100 from right hand side to left hand side, the positive 0.1100 becomes negative 0.1100. So 4.6532 minus 0.1100 equals 4.5432. This is log p. Now in order to find out p, we have to reconvert this log value into real number or anti-log value. So anti-log of 4.5432 is equal to p. Now anti-log value for 0.5432 is 3493. Here the characteristic is positive and it is 4. So number of integral digits will be 4 plus 1, 5. That means there will be 5 integral digits in the result. That means the principal amount is 34,930.00 or 34,930. So the sum borrowed is 34,930. These are the references I used for making this presentation. Thank you.